Yeah, so this was a toy sheet one from the previous semester. Okay, it only had two questions. Yeah, so for this semester, I encourage everyone to put more work compared to last semester because this semester is going to be a bit tricky, especially with farm chem, biochemistry, anatomy, physiology. They're going to be a bit bulky. So we need to work together. We need to put more effort, more than what we did last semester. Yeah, because if you look at pharmaceutical chemistry, this semester you need to know the mechanism because we are moving towards how we are going to be synthesizing drugs. So we need to understand the mechanisms, which are those different structures that you're going to have in drugs are going to be synthesized. So if you are to understand this now, it will help you even in future. This is what you do. You're a pharmacist. Chemistry is your thing. Okay, so you're going to have this chemistry now. Even in fourth year, third year, you're going to have pharmaceutical chemistry. You continue from where we are building up now. So that even when you reach in fourth year, you're going to have your medicinal chemistry, still chemistry. So continue doing chemistry up to wherever you're going to end. Okay. So and I hope people are able to see what's on my screen here. No one wants to confirm. They're able to see. I don't know why. People are feeling shy to talk. So that's what we have there. Okay. Let me just share. There's something happening. It's just loading. Let me just share my screen again. Yeah. So that's what we have. So now I'm starting with the first topic, which is a nomenclature. I'm sure that's the first topic you're going to do when you start learning. Okay. So this is part of organic chemistry. Okay, so like we can see, we only had two questions. So now I want us to understand how we are going to be coming up with nomenclature. Then we'll go back to answering our questions, right? So I want us to understand the rules that we usually follow when coming up with the nomenclature of organic compounds, right? By now, I'm assuming people understand what organic compounds are at this level where we've reached. I hope people understand what organic compounds are and what they are all about. Now we want to know how we are going to be naming this organic compound before we even go anywhere. Okay, so now there are some rules that we usually follow when naming these organic compounds. Okay, the first thing that you need to do if you are given an organic compound is to identify what we call the longest hydrocarbon chain. Okay, so we are given an example here. So in this example, you can see this is a carbon which is attached to another carbon, which is attached to another carbon. There's a branch there, there's a carbon there, there's another carbon there, there's another carbon, and another carbon there. Okay, so now the first thing, if you're given such a compound, is for you to identify which one is the longest hydrocarbon chain. You notice that you can have a lot of path here when moving along this hydrocarbon chain. So we can move like this. Okay, so let me just use a different color. I'll be so that people are able to understand. You'll find that such things people struggle because they overlook them, right? So we need to understand this. Okay, so we can move like that, or we can move like this. Okay, or we can move like that, isn't it? So now the first rule we are saying we need to identify which one is going to give us the longest hydrocarbon chain. Kindly mute your mic unless it's a question. You only unmute yourself if you're having a question. If there is no question, you mute yourself so that we don't get feedbacks. Okay. I'm seeing someone with an iPhone, their mic is on, and studio, I don't know. Yeah, your mic is on as well. Okay, so just be muting yourself as we are joining. Okay. Yeah, so we are saying we identify the longest hydrocarbon chain. So now look the path you are moving. So if we move this path, how many carbons are we going to have? So we're going to have 1, 2, 3, 4, 5, 6. 6 carbons, right? If we follow this path, we are going to notice that you're going to have 1, 2, 3, 4, 5. Okay, so if we move this path, we are going to have 1, 2, 3, 4, isn't it? So definitely the longest hydrocarbon chain that you're going to get if we move in a straight manner, isn't it? So it means that this carbon here, okay, so this carbon here, it means that, okay, so someone said my screen is blank. Let me just reshare. Okay, I hope you're able to see now. I hope you're able to see. Are people able to see now? Kindly confirm if you're able to see. I'm sure it's your network. I don't know, but I'm sure others are able to see. Are others able to see? There are a lot of people in class. I don't know why people are not responding. Let's interact. We have a tutorial sheet to solve. We need to solve this question. So I want us to go through to understand the concept. Then we'll come back and answer these questions here to be easy for us to answer them. Okay, so kindly confirm. Let's interact. Kindly confirm if you're able to see now. Okay. Yeah. So someone has confirmed from the inbox that they're able to see. Okay, yeah, so that's what we do. We identify the longest hydrocarbon chain. So these are the paths I was talking about. Okay, so we move in a straight manner. You're going to notice that you're going to get 6 carbons, right? If we move in this manner, we are getting 5. If we move in that manner, we are getting 4. So the longest hydrocarbon chain is the one that is giving us 6 carbons, isn't it? So meaning the path we are going to use is the straight path. And this carbon there, the methyl group that you're getting is going to be a substituent, isn't it? Okay, so now I'll remind you a bit of something that you did when you are in primary, secondary, the shapes, the types of shapes. You remember if you're getting something with 1, it was meth, right? If you're getting a shape of, let's say, 2 carbons, you're going to say an eth, okay? 3, you're going to say, was it prop? Yes, okay. 4, it was built. 5, it was, um, 5 was what? Okay, so 5 was what? Someone to remind me. So built, number 5 was what? We have 5, what was it? Paint, right? Then if you have 6, it was hex. Okay. 7, it was hept. Okay. 8, it was oct, right? 9, you get a non. Then 10, you get a deck, isn't it? So these are some of the things that you are going to be applying. So in this case, if we are saying the longest hydrocarbon chain is giving us 6 carbon, it means that what we are going to get is the hex, right? And we don't have any double bond in this case, so we are going to get an alkane, right? So in that case, it's going to be a hexane, right? That's what we have. So an alkane will end with A-N-E if it's a parent name. So we have hexane. Then we are having a substituent here, and we're saying we have numbered, let's say, at carbon number 3. That's where we're seeing that substituent that we have gotten, right? And we're saying the substituent is a methyl group. So we are going to indicate the position of that methyl group, which is 3. Then we have methyl. Then we end with the parent name, which is hexane. That's what we have. So that was for the first 2. So identify the longest hydrocarbon chain. I hope people are clear with that one. Okay, the second one is asking us to number the hydrocarbon chain to the nearest substituent. So now, someone would ask themselves, why didn't we number from here, but we started from here. We said this is carbon number 1. Why not starting from the other side? The reason is simple. We want to get our substituents at the lowest number possible. Okay, so if we start from this side, at what position are we going to get a substituent? You notice that this is carbon number 1, right? 2, 3, we're going to get our substituent at carbon number 4, right? And then if we start from the other side, you notice that this is carbon number 1, this is carbon number 2, and this is carbon number 3. So we are getting our substituent at carbon number 3. So the lowest number possible has to be position 3 other than position 4, isn't it? That's the reason why when numbering, we are starting from this side, okay? Going the other side instead of us starting from the other side. That's it, the second rule there. I hope people are clear. Okay, so I can be getting questions if you are not clear. Okay, yeah. Then we go to the third rule. Okay, the third rule is simple. Use the number to indicate the position of the substituent. Okay, so now we have said that our substituent is at carbon number 3, isn't it? So that's the number that we are going to put there. 3 indicating the position at which the substituent is. Then we are going to even name our substituent there. So 3-methyl-hexane. Okay, so I hope people are clear here. We are building up. From here, we're going to go to the next stage. We'll be building up a bit by bit till we get the whole sense of all this nomenclature. Okay, so this thing will always be there. Even in fourth year, you still have to do nomenclature. So if you don't understand now, I don't know, you'll be struggling the entire your academic, you're just struggling with chemistry. Okay, so now we go to the fourth rule. Okay, the fourth rule, we are simply saying the substituent should be listed alphabetically. So now in a situation where you're having a lot of substituent in the organic compound, what we are going to do, we are going to follow the alphabet when listing those substituent. Okay, so for example, let me give a different example apart from this one. Okay, so let's say we're having a hydrocarbon chain looking like this. Now I'll use a skeletal one. Okay, so let's say we're having something like this. Okay, so let's say here. So when you see a group like this, that's an ethyl group, right? This is a ethyl group. Okay, then when you see a group like that in a skeletal, that's a methyl group, isn't it? Okay, so now if I was to number this, okay, or the rest, let's also involve the other rules that we've discussed. First thing, we identify the longest hydrocarbon chain, isn't it? So if we move in this manner, so we're going to notice that you're going to have 1, 2, 3, 4, 5, 6 carbons, isn't it? If we move in this manner, we're going to have 1, 2, 3, 4, 5. If we move in this manner, we're going to have 1, 2, 3, 4, 5, 6 as well, isn't it? So we can either move in this manner or we can move in that manner, isn't it? Two ways, either way is going to be correct, right? So we are saying, let me use a different pen. So we can use in this manner, we can move like that because we're getting 6, right? Or we can move like this. Okay, either way is going to be correct because we're getting 6 carbon, right? Okay, so now I'm going to move like this. So that's my parent name now. So I'm saying it's 6, so it's going to get a hex, isn't it? According to what we've discussed here. So now I'm saying we are building up from what we're having, okay? So we're having a hex and it's an alkane. There's no double bond here. So it's going to be hexane, right? Yeah. Then now we are saying we're having substituent. Okay, so now when numbering, we're saying we want to get the lowest substituent, the substituent at the lowest number possible. So if we start from this side, you notice that the first substituent that you are going to get, you are going to get it at position number. So this is 1, 2, 3 at position number 3, isn't it? Now, if you start from the other side, you're going to get your substituent at position number 1, 2, 3. Okay, so either way, so you can start from this side or the other side is going to be correct because both of them are giving you the substituent at the lowest number possible. But the issue here is the alphabet of the substituent that you have, right? So notice that here we are having a methyl group, right? This is the methyl group here. And then here we are having an ethyl group. So when you see such a group, it's an ethyl group, right? So we have an ethyl group and a methyl group, right? So now the question will be, which one starts first alphabetically between M and E? So you notice that E will come first before M, isn't it? Unless you didn't go through your grade 1. You definitely know that E will come first than M, right? So it means that the first substituent that you are going to list is an ethyl group. Then we are going to go to a methyl group, right? So meaning when numbering, we are going to start from this side. So we're going to have that as number 1. This will be our number 2. This will be our number 3, isn't it? Then this will be our number 4, 5, and this is our number 6, okay? So now at portion number 3, we are having an ethyl group, right? So where the ethyl group is positioned is at portion number 3. So when naming, we are going to say 3 ethyl, okay? So this 3 indicates that portion number 3, we are having an ethyl group, right? Okay? And remember, when coming up with the nomenclature, always start with the substituent, okay? Then also at portion number 4, we've noticed that we are having a methyl group, right? So we're going to say 4-methyl. Then the parent name is hexane, right? So we're going to say methyl hexane, like that. We're done. Okay, so that's how we also consider the alphabet of the substituents that we are having. So we consider the alphabet of the substituents that we have as well. Okay. Now they're saying if two substituents are variable at the same position as a number twice, isn't it? So even when we're having the substituent at the same position, like in this case, you notice that this is an ethyl group, this is a methyl group. They are both at position number 3, isn't it? So we notice that we can also number we can show the numbers like this, isn't it? So this is 3-methyl, 3-ethyl, 3-methyl hexane, still the same thing. So that still counts even if the substituent at the same position. The only difference comes in if we're having substituents which are at the same position, but they are the same, okay? So even if they are different position, but if you're having two substituents in the molecule and they are the same, we are going to consider how many those substituents are going to be. You notice that now we are going to be introducing the di, the tri, to indicate the number of substituents that are going to be there. I hope people are clear on that one. Okay. Yeah. So now we are saying when two or more identical substituents are available, use di if there are 2. We're going to use tri if there are 3. We're going to use tetra if there are 4, isn't it? So that's what we are going to do, okay? And we are going to be using commas to separate this, okay? So in this case, for example, you notice that we are still having the same 6 carbon, right? So we have 1, 2, 3, 4, 5. Okay, so this is 5, okay? So if it's 5, we're going to get the pent, right? Pent, and then we don't have any double bond there, so it's going to be pentane, right? So now, let's check the substituents. At which position are we having the substituents? So we're having the substituent at position number 1, 2, okay? At position number 3, and also at position number 4, isn't it? So at position number 2, we are having a methyl group. At position number 3, we are also having a methyl group. And at position number 4, we are having a methyl group. So now, same substituent within the same organic compound, right? So we are going to use a tri to indicate that we are having 3 of the methyl groups in the same compound, right? Okay, so now we are also supposed to show the position at which those substituents are, okay? So we're going to have, at position number 2, we have a methyl. At position number 3, we have another methyl. And at position number 4, having another methyl. This tri indicates 3 methyl groups, isn't it? Okay, so another example, let's say, let me use a skeletal, okay? So let's say we have a methyl group here, a methyl group here, and then let's say we have an ethyl group here. Okay. So So this will be yeah. So let's say we have what group can I put here? Okay, yeah. So let's try to put this. Okay. Yeah, so let's have that. So let's identify the longest hydrocarbon chain. If we move like this, we're getting 1, 2, 3, 4, 5, right? So if we move like this, we're going to get 1, 2, 3, 4, 5, 6. So this is our longest hydrocarbon chain, isn't it? That's the first thing we said we should do. We identify the longest hydrocarbon chain. Okay, like that. Okay, so that's our longest hydrocarbon chain. Now let's number the substituent. We're having a substituent here, here, and there, right? This is an ethyl group, right? So we're having an ethyl group there, okay? Then here we're having a methyl group here, and here we're having a methyl group, right? So if we were to number, this would be our portion number 1, number 2, this would be our number 3, right? This is 4, 5, and 6. So notice that at portion number 3, we're having an ethyl group, isn't it? Okay, and we are saying when namely we have to start with the one which has the first alphabet. We have to follow the alphabet, isn't it? So this here we're having a methyl, and then these two we're having here we're having 2 methyl and 1 ethyl group, isn't it? So the 2 ethyl, one is at portion number 4. We're having an ethyl group at portion number 4. The other one is at portion number 5. So a methyl group. So okay, so at portion number 4, you have a methyl group. And also at portion number 5, also have another methyl group like that, right? So when naming them, we start with the ethyl. So we're going to say 3 ethyl. Okay, then now at portion number 4 and 5, we are having methyl group, isn't it? So we're going to say 4, 5. Now there are 2 methyl groups, isn't it? So we're going to say dimethyl. So we're going to say dimethyl. Then this is 6, so it's going to be hexane, like that. That's how we are going to name that compound. Okay. All right. Next, if 2 long chains are available, follow the one with a lot of branches. So if in a situation whereby you count, you find that the hydrocarbon, in the hydrocarbon, you're having 2 long chains. Okay, so you can follow the one with a lot of substituents. For example, that the example I have in here. Okay, so if you follow this path, you notice that you're having 7, right? And if you follow the straight one, you're also having 7. But how many substituents are you going to get if you follow this path, right? So if you follow this path, you notice that you're going to get 1, 2 substituents, isn't it? If this is your main chain, we're going to get a substituent here and another substituent. You're getting 2 substituents, right? But if you follow the straight line here, both of them are giving you 7. So if you follow the straight one, you notice that you're going to get 1 substituent there, 1 substituent there, 1 substituent there, and another substituent there. You're getting 4. And here we are getting 2. So we follow the one which is giving us a lot of substituent. And in this case, it's going to be the straight one because it's going to give us 4 substituent. And then this part is giving us 2 substituents only. So that's what we have. So in a situation where you're having two chains giving you the same number, follow the one with a lot of substituents. That's what we have. Okay, so when substituents occur at the same position from either side of chain, choose the one with the lowest number possible. Okay, so that's what we've said, isn't it? So if, for example, here we have, you can notice that here we have position number 1, position number 2, position number 3, and then we have position number 5, isn't it? If you start from the other side, you're also getting the first substituent at position number 2, isn't it? But now, if you get 2 here, the next one would be 3, the next one would be 4. So let's do 2 plus 4, then plus the next one would be 5, isn't it? Okay, so if we add there, you'll notice that you're getting a 9, isn't it? But if you follow the one, the other side, you're going to notice that we have 2 here, okay? We are going to get at portion number 3 and at portion number 5, isn't it? And that is giving us what is okay, so here this is 11, right? Then here this is 10. So you notice that the one which is giving us the least number possible is the one with the 10 there. So it means that the first the counting should be in that way instead of the other way, isn't it? Because that's where we're getting this number of substituents possible. That's what we have. So those are some of the rules that you need to follow when coming up with the nomenclature. Okay. So now the other thing that I want to make mention is that in the case where you're having functional groups. Now we need to, I'll send the table in the group of the functional groups with the priority. So you need to follow, you need to ask yourself which of the functional group has high priority. The one with high priority is going to carry the parent name, isn't it? Okay, so do that as we are solving question. Notice that we're going to get such examples. Okay, so now let's go back to our tutorial sheet. Now we answer our questions. Okay, so let's start with the first one, saying provide the IUPAC pack names of the following hydrocarbon shown. Okay, so we have the first one here, which is saying we've been given this guy here. Okay, now there's a methyl group there. Okay, so now the first thing we are saying, we need to identify the longest hydrocarbon chain, isn't it? So now the question is, which path are we going to use here for the first question? Okay, so if we follow this path, you notice that you're going to get how many carbons? If you follow that path, you're going to get 1, 2, 3, 4, 5, 6, right? If you follow the other path, you're going to get 1, 2, 3, 4, 5, 6 as well. So either path is correct, isn't it? So you're going to have a 6 carbon carbon molecule there, which is going to be Higgs, right? Now Higgs, there's a double bond in this hydrocarbon chain. Okay, so when there's a hard double bond, you know it's going to be an alkene, isn't it? So an alkene will end with E-N-E. So it's going to be hexene. Okay, so that's what we have. Okay, now the other thing that we need to take note of, whenever you're having an alkene on an alkyl like that, you need to indicate the position where that double bond is, or the triple bond where the triple bond is, isn't it? Okay, so now in this case, if we are to follow that, you notice that we're having a double bond here at position number 2. Again, when numbering, you have to make sure that you get the double bond at the least number possible. So in this case, you notice we have a substituent here and a substituent here, but we have a double bond here. So instead of first numbering from this side, if we number from this side, you notice that we are going to get a double bond at position number 4 here, right? But if we number from the other side, you're going to get a double bond at position number 2. So you want to make sure that you get the double bond at the lowest number possible. Okay, so now in this case, we're going to say the numbering start from this side, okay, because we are going to get the double bond at position number 2, which is the least number possible. Okay, that's what we have. Okay, so we get the double bond at position number 2. So if the double bond is at position number 2, we can indicate that here by putting a 2 here. Or we can say this can be hex, then you put a dash, you put a 2, then you end with I-N-R-E-N-E, like that. So hex 2 in. So either ways, this way or that way, it's going to be correct. Okay. All right. Then, we've identified the parent name. The next thing that we want to do is to identify the substituent, which we are saying a substituent there and a substituent there. One is at position number 2, the other one is at position number 5, and both of them are methyl. So we are going to say 1, 5. So we are going to say dimethyl, right? So we are going to be dimethyl. Okay. Now we are saying this is hex 2 in, right? Or we can say 1, 5 dimethyl. We can now indicate a 2 there to indicate the position of the double bond, like that, hexene. So either way, this way or the other way is going to be correct. That's what we have there. Okay, so that's for question number 1. Okay, so I'm going to go to the next question. I'll leave this question. So what you can do, you can try solving them, and then you share in my inbox what you're going to solve, and then I'll look at them. Or you can go on the website. If you are able to subscribe, you can subscribe, Then you check out, I'll show you where you can find this video solution to the tutorial sheet that we have solved for last semester. Okay, so but let's also answer a question from the second part. Okay, question number 2. So it's saying the following names are incorrect, isn't it? So we're given the names which are incorrect. Okay, so they are saying draw the structure according to these names and write the correct one. So we have to draw the structure and come up with the correct one, the correct name that we are supposed to give that structure, isn't it? The ones that we are given here were wrong. Okay, so the first one, we are having a 1-methyl 5 methyl cyclohexane, right? So that's what we have. So if we were to draw this, it's a cyclic link. Cyclo, it means that you're having a cyclic link as a parent chain, right? And then we're having hexane, right? Hexane. So it means that the cyclic link has no double bond in it, right? So what we are going to do, you know, hex is going to be a 6-carbon molecule, isn't it? And it's a cyclic link. So that's a hexane, right? And then that's cyclohexane, right? We don't have any double bond. Okay, and then we are saying at portion number 5, we have a methyl. Okay, so you can number it anywhere. So you can number, you can say this is your portion number 1 anywhere. This can be your portion number 1 anywhere you decide. Okay, so let's say this is our portion number 1. Okay, and they are saying at portion number 5, which will be this one, we have it a methyl group. And then at portion number 1, they're saying at portion number 1, we have in an ethyl group, isn't it? An ethyl group which looks like that, right? Now they are saying this was wrong in terms of nomenclature. This is the structure that we had, but in terms of naming it, this is wrong. Let's provide the correct naming. So you will notice that with this one, what was wrong is the path in which we follow, right? So we are saying this is our carbon number 1, right? So this is our carbon number 1. Now the question, when numbering, should we go this way or the other way? That's the question which was there. And you notice how they were naming this one. They moved this side because they said this is position number 1, number 2, number 3, number 4, number 5, okay, so this is number 1, number 2, number 3, number 4, number 5, number 6, isn't it? So I drew the long one. So portion number 5 has to be here. Okay, so the methyl group is here. Yeah, so this is portion number 5, and that is portion number 6, isn't it? So that's what they did here. They moved in that manner, which is wrong because if you check the lowest substituent possible, it's destroying that, isn't it? We're getting at portion number 1 and number 5. Portion number 1 plus 5, which is giving us 6. But if you follow the other path, which is this side, you notice that you get at portion number 1, this will be our portion number 2, this is our portion number 3, isn't it? So we get 1 plus 3, which is giving us 4. So this is the lowest number compared to the other one. So the correct nomenclature, we are supposed to move this side instead of moving the other way around, isn't it? So it means that the correct nomenclature was supposed to be like this, and we are going to correct the name there. Okay, so this was our portion number 1. We are having a methyl group, an ethyl group, and this is our next position, isn't it? So we are supposed to number it. This is our portion number 1, number 2. This should be our portion number 3, and the correct name should be 3 ethyl, then 5 methyl, then you'll end with cyclohexane, like that. That's how you answer such a question. Okay. Yeah. So we also have these other questions which were solved, and the solutions are on the website. So let me just show you how you can access those solutions on the website. So you subscribe to the course of your choice. Once you subscribe, so how you can subscribe, you go on the on your browser, you can search Discrete Learning Institute. Okay. So let me just search Discrete Learning Institute. Okay. Once you search, it will take you to our website. You're going to see the courses that are available there. Okay. So once you find the course that, of your choice, for example, pharmaceutical chemistry, you are going to see there, you subscribe, you are able to access the course like that, right? So once you enter in the course, you're going to open, let me wait for it to open. You're going to see these folders, there's semester 1 and semester 2. So you go the folder written semester 2. So you open there. Okay, let me just wait for it to load. Okay, okay. Is it taking time? Okay, okay, all right. So let me just wait for it to load, then proceed. Okay, yeah. So once it enters that folder, you're going to see other folders in there. Okay, don't know why it's not opening. Okay. All right, so when you enter in that folder, you're going to see the one written tutorial sheet and assessment. So you can just go there, you find your tutorial sheet one for this, that was January intake. So you go in that folder, you should be able to find the full video solution. And also the topic lessons, just go on the one written Introduction to Organic Chemistry. You should be able to get other videos when it comes to nomenclature. Okay, we'll end here unless there are questions. Okay, so if there are no questions, we'll end here. We'll meet next time with the other things. Thank you so much.